All right, we're reviewing for our post-test, second semester of Algebra 2, 2018. So, this test is a little lengthy, so we ended up dividing it between 2 days. And I will say there's probably more time commitment on the first day than the second, but I think that's probably better for everyone involved. There's a little more writing and thinking, I think, in the second part. So, anywho, number 1 and 2, this is on the first part of the test here. I'm going to give you two functions, f and g. And the first thing I'm going to ask you to do is do some sort of operation. So this example here says g minus f. Now, I know that seems like an easy question, but kids still mess it up. So we have function g, which is x squared minus 2. And then when you subtract function f, you can't just simply write down 4x minus 3 next to it like this. You have to remember that you're subtracting the entire function, which means you're going to be distributing the negative here and here. So I really encourage you, because this is an important test, to show a little extra work than normal, because we're just grading this old school style, so if it's wrong, it's wrong, and you don't get your point. No matter how big or small your mistake is, you don't get your point. So let's distribute the negative, and now we can collect our like terms. So I like to write answers in standard form. This is x squared, and then we have a minus 4x. And then I'm combining this negative 2 and this plus 3 together, so that's a plus 1. Clearly the most common mistake there would be students who do not distribute the negative or the subtraction all the way. This following question here is called function composition, and it's f of g of 3. And the way we compose two functions at a number is we start on the inside of the composition and we find out what g of 3 is. So take function g, plug in a 3. Let's see, we got 3 squared, which you should get in the habit of using parentheses. 3 squared minus 2, which is 9 minus 2, which is a 7. Now, that's not the end of the story, though, because if this is 7, now it says find f of 7. So that's what we're going to find out, and that's actually going to be the answer to our question. So function f with a 7 plugged in would be, what, 28 minus 3, so 25? The second answer you get, the final answer, that is your actual answer. So make sure you're putting that on the line there. If you need more practice or a refresher on this lesson, oh boy, let's see, this is lesson, this is called function operations. I don't think it has a section number necessarily. But if you look in the remediation bin, there's a whole pile of practice problems there. You can go review the lesson. You can go look at an old test to see what we asked you, and you can redo problems. These are pretty easy to make up your own problems. So have a friend make up a problem for you. All right, here, transformations of the logarithm. We are asking you to identify right, left, up, down, and it's every transformation that we've ever known in math. Same way, right? So this is the horizontal function, but when it says plus 6, we know that really means left 6. There's a built-in negative in the formula for the horizontal shifting, so it's x minus negative 6. That's why it's left 6. But the vertical shift does exactly what you think it does. So a negative 3 off to the side is a down 3. Again, you could ask somebody to make up some problems for you. This is section, oh boy, 7.3. No, it's not. Yes, 7.3, 7.3b, technically. So it's part of lesson 7.3. I think we separated it in the gradebook into 7.3b. All right, here we go, trig functions. This is a little newer. I give you a function. I want you to tell me the period and the amplitude. Now, this is not the order that we usually ask us in, so be careful. The period, it has to be calculated. Usually it's 2 pi, but it's 2 pi divided by b. So I notice in my function here, the b is a 2. So 2 pi divided by 2 is going to shrink the period down to just pi. We'll come back to that thought. The amplitude is the absolute value of the number in front of the function. So the amplitude is 5. And now I'm going to ask you to graph 2 cycles. Notice 2 cycles of that. So, using my graphing tools, because I need all the help I can get. It's probably a little ambitious, you don't need to graph that far out. The midline is still at 0, amplitude of 5, so positive 5 and negative 5. Make sure you label your axes. And we're going to be graphing 2 cycles starting here at 0. So 1, 2, 3, 4, 1, 2, whoops, 3, 4. It's not very symmetrical. Now I got to figure out what to label that. Well, it's the quarter point, right? The quarter point is the entire period divided by 4. So let's start counting by pi over 4. Please reduce when you are done. 1 pi over 4. This is 2 pi over 4, which you can come back and reduce that to pi over 2. Then we have 3 pi over 4. This is going to be 4 pi over 4, but that's pi. Okay, there's the first period. Keep going. So that was what? 4 pi over 4. This is 5 pi over 4. 6 pi over 4 is going to be 3 pi over 2. This is 7 pi over 4. And this guy's 8 pi over 4, which is going to be 2 pi. And that's the end of your second period. Now we have to remember what they're wanting me to graph, which is cosine this time. Cosine starts at the maximum. And then every quarter point it hits the next line. And then it continues on. There's the end of the first period, and then keep on going. We should end back at the top. And we did. Alright, so then we... Oh boy, that's getting ugly. Okay. Oh man. Alright, so I'm on a tablet. You know, you gotta give me a little grace here, guys. That's not great. Alright, but I do want to notice before I leave this question, there's the end of the first period, here's the end of the second period. I have 2 full cycles and everything's labeled. Alright, I feel good. That question itself is worth a few points, so make sure, I mean, you shouldn't be skipping anything on the test, but because we're going back to the old style of grading and you guys are so used to the 5, 4, 3, 2, 1, you have to really be accurate like 100% of the time. You can't afford to lose points on stupid mistakes because they're just going to be wrong. So I hate to tell you that, but yeesh. Alright, here's your function. They want us to build the function first. So remember the number in front represents the original cost, or the original amount, which is $39 in 1980. So they're pretending like time starts in 1980. And then the formula, you either add or subtract the rate, depending on whether it's increasing or decreasing, and it says here it's increasing. So increasing, careful with the 4.1% though, guys. 4.1%, if you're not sure what decimal that is, go ahead and divide it by 100, and you get 0.041. I don't even need you to simplify this, guys. You can just leave it t, x, whatever power you want. But now when it says, what's the cost of the room in 2020? Well, we're going to need to think about how many years have passed. So remember how they're pretending like time started in 1980? So how many years have passed between 1980 and 2020? Well, that's 40 years. Oh my gosh, my pen's not working. It's going crazy. Here we go. So t, or time, or x, or whatever you're calling it, is 40 years. So we're going to just plug in a 40. You guys can use your table. I would just go on my home screen and type 39 times 1.041. You don't have to simplify it, but you can. And then up here in the caret exponent to the 40th power. And I think I get, make sure you do practice this, 194.58. And then also think about your answer and make sure it's reasonable. Sometimes you guys do some weird math and then you end up with, like, if you put a subtraction sign by accident and you got the room was worth, you know, $12 in 2020. Like, a hotel room doesn't cost $12, guys. Come on. Alright, so here, this is the newest stuff we've learned. And yes, it is on your post test. That's why we're hitting it hard here at the end. So we have a chance to sketch it, and I really think you guys should, because it works out well when you sketch it. Got a max, got a min. Let's figure out what those numbers are. So the buoy reaches a maximum of 10 feet, that's the height, and a minimum of 2 feet. Talk about time in a minute, but let's figure out that midline. So 10 plus 2 divided by 2. Make sure you add those before you divide by 2. So that's 12 divided by 2 is 6. And then I do a double check to make sure the amplitude is symmetrical, so it should be the same units up and down. So it's 4 units up and 4 units down. So we just stumbled upon the amplitude being 4. We have never given you one on a test where it's sneaky and the A value has to be negative because of reflection, and I'm not going to start on the post test, so don't worry about that. And then they give me some times here, guys. So it says it reaches a maximum at 4 a.m. and a minimum at noon. And it does say somewhere here t equals 0 represents midnight. So right here's midnight, 0 hours, so they're going to measure how many hours out. And they told you 4, which is your quarter point now. So you're counting by 4 hours. 4, 8, 12, keep going, 16. So 16 hours after midnight does represent 4 p.m., but remember, we got to measure army time style. It reaches high tide at 4 a.m. and low tide at noon. So you do get, oh geez, you do get the sine function. There we go. And you guys got to fill in the function itself. So it might help. Oh, it's right here. But that's what you're going to fill in. So you need to figure out A. I already know it's sine. You need to figure out B. We're going to use T for the variable. And you got to figure out the midline, K. I think we actually have almost all of those pieces of information. For instance, 6, the midline, goes right here. So plus 6. And you actually have A. Amplitude is the size of the wave, so it's a 4. We'll put a 4 right here. So the only thing you have left to do is figure out the B. And B is calculated. This is not given to you this time, so you do have to remember this. It's 2 pi divided by the period length. Well, how long did it take for this buoy to go through a full cycle is 16 hours. So 2 pi divided by 16 hours is, this reduces to pi over 8. 1/8 pi, or pi over 8. And that's what goes inside the sine function. So there you go. The picture helps develop all those pieces and make sure they go in the right spot. That's the most common mistake for kids, is they're putting their A and K in the wrong spot. Alright, this guy. I'm actually going to do this without a graphing calculator if you don't mind, because we've been reviewing this quite a bit in our class. This is an exponential decay graph because the base is smaller than 1, and it's been shifted down 4. So 1, 2, 3, 4 means the horizontal asymptote is now here at -4. So if I sketch in the world's ugliest, whoopsies, I wasn't supposed to cross the line of the asymptote there. My bad. Alright, so it looks something like this. And I don't really need more detail than this because they just want domain and range and then end behavior. And these are 2 separate questions on your test. You get this as a question and this as a question. So domain for exponentials are always going to be -infinity to infinity because it doesn't matter what you do to this graph, it's going to go forever left and right. But the range is going to start at the horizontal asymptote, but it doesn't actually get there. So use a parenthesis and say the range is from -4 to infinity. It has to be low to high. Has to. I'm so sorry if that just messed with your eardrums. I was coughing in the microphone. Okay. Alright, end behavior. You get this template. You got to fill it out. So the part of the template that if I was nice I'd fill out for you is this, because this does not change for us. X goes to -infinity and positive infinity are the 2 ends that I'm referring to. And then X goes to -infinity means the left end. And X goes to positive infinity means the right end. So look at the ends here, guys, on the left. The function's going up, so we say that by saying infinity. And then on the right, the function's trying to hit the asymptote, which is at -4. It doesn't quite get there, but that's not what end behavior is saying. It just says, what is it approaching? Alright, so far so good. Oh, the dreaded clock problem. Most common mistake from your friends was that they forgot theta had to be in radians. So whenever we see this question as an error analysis question, I try to incorporate that into our problems where, you know, whoever tried to do the question never converted to radians. Because yes, on a clock, the minute hand does make revolutions. Between 6 a.m. and 11 a.m. it's going to make 5 revolutions. So a lot of kids do this and they multiply it by 360. Well, you can't multiply it by 360. Well, you can, but you'd have to go convert because 360 is degrees and we want radians. So I think about how big is a rotation in radians, and that would be 2 pi. Every circle, every rotation is 2 pi. So 5 revolutions times 2 pi means that your angle of rotation is actually 10 pi. Because it has to be radians. Alright, so the radius of the clock, don't confuse that with radian measure, the radius is 6.5. Ladies and gentlemen, I think we're ready to rock and roll. The arc length, the distance traveled, is radius times the angle in radians. And then, I don't know, that probably comes out to some gross decimal. Let's see if I wrote it down. Yep, 204.2 inches. And I would prefer you guys just to go ahead and type the pi in. What I've noticed for most kids who don't do that is they forget about pi being attached to the answer, and they might write like 65 instead of 65 pi. So that would not be right. Alright, so this question is number 9 on the review packet, but it's actually on part 2 of the test. In case you're curious, what you're going to do is you're going to graph this in your calculator, and you're going to, I don't know exactly what it looks like, something like this, but you're going to look and see where it crosses the x-axis, and you're going to find all these zeros. We'll come back to this in the second part of the review. This is still on day 1 of the test, though. So they want me to factor this 4-term polynomial. So we're going to use what's called grouping. You do not get to use your flowchart, so you have to know that. So you group the first 2, and then you group the last 2, and you take out the common factor for each group. So this group here has a common x squared that you could take out. And when you remove an x squared, divide by x squared, you still have a 2x plus 3. So we're undistributing that x squared. The second group here, that's a positive sign right here. This is an 8x plus 12, so I can factor out a positive 4. Got to go as big as possible. And when you factor out a positive 4, you better be left with 2x plus 3, otherwise we messed up. The reason factor by grouping works is because once you take the common factor out of each group, the leftover component should match the other leftover component. Because now, you're going to factor that 2x plus 3 out in front of the whole problem. And once that's taken out of the problem, you write down what you're left with, which is x squared plus 4. And of course, we always want to watch out for extra factoring. X squared plus 4 does not factor any further, so that's going to be our answer. 2x plus 3 times x squared plus 4. Sometimes kids like to write these in different orders, the x squared plus 4 first. That is fine. It does not matter. This, oh, I keep forgetting to tell you what sections these are. Haha. Grouping, this is advanced factoring. That's what we titled that. A whole bunch of practice problems there in your notes and on the remediation page. We'll come back to that later. This is called sector calculations. This one is 7.1, 7.2a, graphing exponentials. Well, this is clearly trig modeling. The last thing we learned. This guy is 7.1, 7.2b. This is applications of exponential growth and decay. This is trig graphing. This is 13.4 and 13.5. One was sine, one was cosine, but we learned them together. Transformations of logs. We covered that one already, 7.3b. Alright, now that I'm back on track. Alright, so we're still going to be on part 1 of the test here. And Jenna is going to be asked to factor this polynomial. And she did. This is her answer. And if I was grading Jenna's test, I would have, kind of circled this and wrote something like, keep going. Because Jenna's not done. The x squared minus 16 is the difference of two squares. So no, she's not completely factored. I like that she took out the 3x. That was correct. But x squared minus 16 factors again. Now what I need you guys to worry about, a lot of you would factor that again and then you'd lose the 3x. That's not quite right. Alright, x squared minus 16 factors into x plus 4 times x minus 4. Alright, so we're still on day 1 here. We're going to be simplifying this rational expression. We have a multiplication followed by a division sign. So, I'm going to leave the x plus 8. That is not factorable, and if you want to put parentheses, you can. This 4x minus 5 is also not factorable. I'm going to put it over 1 though, so I know it's in the numerator. This, however, part of it's factorable, and it's division, which means I need to flip it to change it to multiplication. So the x plus 8 is going to come up to the numerator. So we're flipping this around. And the 16x squared minus 25 factors into the difference of two squares pattern. So that's 4x plus 5 and 4x minus 5. Now this is one big fraction problem. So I cross off what I can. Fruit Ninja, ready? Gone, gone, gone. Make sure you get the right one. Gone. And we still have 7x in the numerator. And we still have a 4x plus 5 in the denominator. And I love when you guys leave these in parentheses, so that way you don't do any crazy factoring at the end that doesn't, or canceling that doesn't actually happen. Alrighty. A little bit more here. Adding fractions, which means we need a common denominator. So the common denominator here is an x minus 5 times an x plus 1. So this fraction is missing the x plus 1. And remember, I already set up the denominator, so I don't actually have to do any more work here. And the bottom. And the top, yeah. Alright, x minus 5 is what we're missing over here. So denominator's good to go, but this numerator needs some simplifying here. Let's clean this up a bit. So x times x plus 1, I'm going to distribute that. I'm going to make it x squared plus x. And then we have a plus 3 that we're distributing into x minus 5, so plus 3x minus 15. And the only thing I'd expect you to do after this is clean it up. So x squared, this is plus 4x minus 15. Now good news, that does not factor, which means our work is done. Alright, there we go. Easy peasy lemon squeezy. Alright, next question. I just want to know what the least common denominator is. So this is a conceptual issue that some of us had, where we weren't sure what x and x plus 6 and how they related to each other. Well, sorry if you can hear the bell. They actually don't relate to each other because they're two very different numbers. So your common denominator would be both an x and an x plus 6. And that's the most common mistake in that question, is kids don't realize what the common denominator is. All right, so that is the end of day 1 of testing. It's approximately 14 questions. Some of them are split into multiple parts, but you're going to be testing the whole hour, and you're going to concentrate, and it's a one-shot deal, guys. You don't get to retake this. This is part of a major part of your final, and we need to make sure that we get a good score on it. All right, next video is going to be part 2.